about polynomials today. And believe it or not, we've already been talking about polynomials. We just didn't call them polynomials. We called them linear equations, okay? So if you look at x plus 3 equals 2x minus 1, that's a linear equation. We can graph it, we can solve it, and we can talk about it, okay? And we can identify intercepts and all sorts of stuff because it is a linear equation. And we're very used to seeing that linear equation. Now, if I have an x value right here, sometimes students will put a number in front of that value. What number do I put in front of that x? A 1. And that helps us when we're adding and subtracting when we're simplifying or when we're solving equations. Sometimes that 1 helps us to think about that and we don't forget about it. The same is true for exponents. When I have a linear equation or a linear expression, okay, there is a 1 right here for my exponent. So a linear polynomial has an exponent of 1, even though that we don't see it. So we can write it. Just like we can write that coefficient, we can write that exponent. So for this particular problem right here, my degree is 1. So we are looking for my highest exponent. Okay? The degree of a polynomial is your highest exponent. Okay? Your highest exponent. Now, the second one that we're going to be looking at is a quadratic. Okay? You've probably, oops, I thought I had my top on. You have probably seen quadratics before. You have factored them, and you have probably even solved them. And the graph of a quadratic is a parabola. And a quadratic has an x squared. That's what makes a quadratic, is the squared, x squared. Now, do I have a linear exponent in my quadratic also? Do I have an exponent raised to the first power in my quadratic? Yes, I do. Okay, so I've got x squared, which is to the second power. Then I have 2x. That's called a linear term, but it is not used to determine the degree. When we're determining the degree, we look at the highest exponent. And we also do not add them together when my terms are being added. So I want to distinguish that just a minute. This x squared is being added to this 2x. This is an individual term, and this is an individual term. This 2 determines the degree of the whole thing because it's the highest exponent in that term has the highest exponent. Okay? Now, when we go down one more and we get raised to the third power, that's called a cubic. Sometimes, definitely in 144, you'll hear me say this is a cubic. Okay, that just means it's raised to the third power. And when it's raised to the third power, my degree is 3. Okay, I ignore those exponents. I'm only worried about this term right here. I'm worried about that term right there. And I am worried about the degree of that specific term. Now, we can go to the fourth power. We can have x to the fourth power. That's called a quartic, like a quarter, a quartic. Okay? After that, it's just raised to the fifth power, raised to the sixth power, raised to the seventh power. Okay? That's what they're called. Now, tell me what's different about this one right here and all of these. What's different? Okay, that's exactly right. Okay, in our first 3, we only had an x. We had an x to the first, an x squared, and an x to the third. Here, I've got an x squared and a y to the third, and they are being multiplied together. This right here is a term. That is an individual term. This is an individual term. This is an individual term. And we are looking for the highest degree or the highest exponent per term. Okay? Per term. When you've got two letters in the same term, you've got to add those together to determine your degree. Now, I'm not going to add x to the third and x squared together because what operation is happening between those two? In the one up. In x to the third plus 2x squared, that's addition. So I'm not going to add those together. What's happening here? Multiplication. So I do add these together. So the term for, the degree of just that first term is when I add these two together. So what's the degree of that term? 5. Okay? What's the degree of this term, my second term, x to the third y? It is 4. So don't forget you've got that 1 right there. So what would the degree be to the last term? 2, because you've got x to the first, y to the first.
So you can add them even though they're not like terms?
Okay, so you are thinking about x squared times x to the third. Okay, and x squared times x to the third is x to the fifth because we're multiplying them together. We aren't doing that here. The only thing that we're doing here is we're determining the degree. Okay? We're not combining. What we're doing is determining the degree. That is an excellent question, and it will make a lot more sense on Wednesday. Okay? All we're doing is determining the degree. And determining the degree of a polynomial is a very minor, I don't even think I have questions on the test on it. Okay? It's a very minor part of this chapter. Okay? But the degree of this polynomial right here is 5. That's the degree of this polynomial. Okay? So let's look at the degree of a couple. Can I move off this screen? Okay. Here we go. I have 7xy plus 6y. All I'm doing here is determining the degree. That's all I'm doing, determining the degree. Okay? So for my first one and my last one, I have more than just one variable. I've got x and y in both of those. So for this term right here, what's the degree of that term? 2, because I've got the 1 and I've got the 1. What's the degree of this term? 1. What's the highest one? 2. So the degree of this is 2. Okay? 5x squared minus 7x minus 2. That's a quadratic. We don't have multiple letters. So what's the degree of this one? 2. Okay. Negative 12 is what we call a constant. Okay, that means it is not being multiplied or divided by a variable. Negative 12 will be negative 12 all the time. If I were to graph this, it would be a horizontal line if I were to graph it. Okay, it would be a horizontal line. Now, you can think about this. You can think about this if you think about x to the 0. X to the 0. Negative 12 would be the coefficient, x would be the variable, and 0 would be the exponent. Be very careful, and we'll talk a lot about this on Wednesday. Does anyone remember what x to the 0 power is? It is 1. Anything raised to the 0 power is 1. Okay? So x to the 0 power is 1. So I have negative 12 times 1, and that's going to give me negative 12. What is the exponent right there? 0. So the degree of all constants are 0. Okay? If you don't have a variable, your degree is 0. Think about what's the slope of a horizontal line? And I know we haven't talked about that in this class.
0.
It is 0. So it kind of goes back with that. Okay? Now, I'm going to give you about 30 seconds. I want you to determine the degree of the last one. Okay? What's the degree of this term right here? Good. What's the degree of this term? Which one's higher? 6. So the degree of this is 6. Okay? So that has a degree of 6. Yes?
So there'll be questions just like this on homework?
There will be on homework, yes. Yes. Yeah, you're like, yes. Can you give us all questions like that? Yes.
Is the homework already up?
Yes, it is. Okay? Okay. Now, let's define some of these. These are actually not on your homework, and you don't have a vocabulary test. However, you will hear me say these sometimes. You'll hear me say monomial, you'll hear me say binomial and trinomial. So I want you to know what those are. When I say the term monomial, I am talking about one term. Okay, I'm talking about one term. And in that term, we are multiplying and dividing only. Okay? We are multiplying and dividing only. Okay? For something to be a monomial, you are not going to have a variable in the denominator. No variable in denominator. Okay? That is for something to be a monomial. So some examples of monomials are 5a squared. That's a monomial. X is a monomial. Negative 2y is a monomial. Okay, I think we had like negative 2x to the third, y to the fourth. That is a monomial. Negative 12 is a monomial. It is one term. One term. Oh, something else I want to write as a monomial is, let me do it right here, 1/2 x and x over 2. Both of those are monomials. Okay? All of those are monomials. They are one term. You can be multiplying and you can be dividing in that term, but it is just one term. Okay? Now, for something to be a binomial, that means we are going to have two monomials or two terms. And we are going to be adding or subtracting those two terms. Okay? For something to be a binomial, you've got to have some addition and you've got to have subtraction. For something to be a binomial, there must be. Okay? We FOIL binomials. That's something that we'll learn on. Okay? 2x squared minus 3, binomial. X minus 1, binomial. XY minus 1/2 is a binomial. Fractions are allowed as long as you don't have a denominator in the fraction, or a variable in the denominator of the fraction. Okay, fractions are allowed, but you can't have a denominator there. We FOIL binomials. Okay, so you're going to see lots and lots of binomials. So if a monomial is one term, a binomial is two terms. Any idea what a trinomial is? 3 terms. Okay, 3 terms or 3 monomials. You are going to add and you are going to subtract. Okay? These are what we factor. We do a lot of factoring with trinomials. It looks like x squared plus 3x minus 1. That's a trinomial. X to the fourth plus x squared plus 8. That's a trinomial. X squared y to the third plus 2xy minus 3. That's a binomial or a trinomial. 3 terms. 3 terms. Yes, ma'am.
Can you have variables in denominators to try to?
You cannot. None of these. No variable in denominator. Great question. So none of these can have a variable in the denominator. Okay. Now, we do a lot with monomials, binomials, and trinomials. Okay? 1 term, 2 terms, and 3 terms. We will do a little with 4 terms. Okay? We won't go past that. But we'll do a little bit with 4 terms. Polynomial includes all of this. Okay? A polynomial can have 1 term, 2 terms, 3 terms, 4 terms, 5 terms. Okay? So a polynomial is made up of monomials. Okay? The definition of a polynomial is it has to have a smooth curve. And we're not going to do a lot of graphing in this class, but that will come up later. Okay? A polynomial has to have a smooth curve, and its domain has got to be all real numbers. Okay? No denominator with a variable. Okay? That's important for the definition of a polynomial. Okay? Now, an example of a polynomial, and really probably the most that you'll be dealing with, 4x to the third plus 2x squared minus 8x plus 4. Okay? That's a polynomial. All of them are polynomials, but that's a polynomial that you might see. Okay? Is it okay if I go to the next screen? Nope. Okay. Okay, like terms. Now, we have already been combining like terms. Okay, we've already been combining them. Like terms are when we have the same variable. And we mostly dealt with variables to the first power last unit. Now we're dealing with variables that are raised to different powers. So for something to be a like term, it's got to be the same variable raised to the same exponent. Okay? Your coefficient is the number in front of your variable. Okay? So right here for 2x squared, this is my coefficient. This is my exponent. Okay? So here's my coefficient. So your coefficient is the number in front of your variable. What's the coefficient in negative x squared? What's the coefficient there? Excellent. What's the coefficient in x squared? 1. Okay? Okay, so like terms, same variable, but it also has to be raised to the same exponent. So, not like terms An example of two terms that are not like terms is 2x squared and 3x. Those are not like terms. Even though they're the same variable, they're not raised to the same exponent. Okay. Don't hesitate to take pictures if you need to. Don't hesitate to take pictures. Okay. Now we are going to start combining monomials. We're going to start adding and subtracting them. Okay, so here we go. So we have a trinomial, and we are adding that to another trinomial. You ask yourself two questions. The first thing you ask yourself, is there anything inside the parentheses that can be combined? So I am looking at the first set of parentheses right here. I'm looking right there, and I am asking myself, is there anything in there with like terms that I can combine? No, there's not. Okay, what about the second one? No, there's not. The second question that you ask yourself is there anything that needs to be distributed? And we will deal with this today. Is there anything that needs to be distributed?
Well, you could distribute one just to get rid of the
And we're going to drop the parentheses because we're able to answer no to both of these questions. Okay, so that's what we're going to do. So when you've dealt with both of these, that's when you can drop the parentheses. Okay? Is there anything that needs to be distributed? No. So when you've dealt with that, you can start combining terms. Okay? So I have 4x squared plus 5x plus 1 plus 7x squared minus 9x plus 4. Okay? So now I'm looking for like terms. I have 4x squared and 7x squared. 4x squared plus 7x squared is 11x squared. Okay, then I have 5x and negative 9x. 5x and negative 9x is minus 4x. And my last set of like terms are 1 and 4. Now, that's my final answer right there. That's my final answer. But always ask yourself, can this be simplified any further? Did I miss something? Okay? Did I miss anything? Usually the answer is no. Usually you've gotten it all. But always take just one more look just to make sure there's nothing else that can be combined. Okay? Now we are going to add 3 binomials together. Are we ready? Okay. We ask ourselves, what do we ask first?
Is there anything inside the parentheses that can be combined?
Good. Is there anything inside the parentheses that can be combined? No. There's nothing inside the parentheses that can be combined. Do we have to distribute anything? No. Not yet. We're about to have to distribute, but we don't have to distribute yet. So I am able to just write this down. Now, some students just deal with it inside the parentheses, and that's totally fine. But I like to highlight like terms. Okay. So, negative 4x squared y. That is different than xy squared. In negative 4x squared y, my x is squared. What's squared in the xy squared? Xy squared. What's squared in the next one? The y. Okay, so those are not like terms. Negative 4xy squared and positive 7xy squared, those are like terms. So what do I get?
3x squared.
What do I get?
3x squared.
3x squared y. Okay. Next, I have xy squared. Whoops, I'm sorry. Xy squared and negative 9 xy squared. Oh, yes. Thank you. Yes, thank you. I just saw it. Thank you very much for pointing that out. Right here we got another one. I missed it. Okay? So I've got negative 4x squared y, 7x squared y, and 5x squared y. So what should this be? 8. Thank you very much for showing me that. 8x squared y. Now let's go to our next one. Xy squared, negative 9xy squared, and minus 4xy squared. What's in front of that xy squared? What can I put in front of it? I can put a 1 right there. Okay, so I have positive 1, negative 9, and negative 4. Good. So I've got negative 12x y squared. Okay. Now, addition. Students tend to not have a ton of problem with addition. Okay? The one thing I do want to comment on, do you see this right here, this minus 9? That minus belongs to that 9 in the same way that this minus belongs to that 4. Some students choose to rewrite that as plus negative 9 and plus negative 4, and that is fine. I typically don't. I just want you to realize who that minus belongs to. So don't drop those negatives. Be super careful with that. Okay, here we go.
Couldn't you have simplified it? Also,
You can factor it, but you cannot simplify it further. Because this is to the second power, and this is to the second power. They're not the same. So you can't simplify it further. You may be thinking about factoring.
I think.
Yeah. Okay, now, what we're doing now is we're subtracting. When we subtract, we do have to distribute. We do have to distribute. We have to give that negative sign to everything. I just want you to look at this terminology right here because this terminology does show up in WebAssign and you are subtracting. This is saying subtract this from this. Okay? Subtract this value, this quantity, from, that's your key word, this quantity. So I need to write this quantity first. Okay? So this is going to be 7x squared minus 2x minus 4 minus 3x squared plus 7x minus 1. Now, I don't have anything in that first trinomial that I need to distribute or combine. I don't have anything, so I'm just going to write it down. So I have 7x squared minus 2x minus 4. Now, this negative sign, I have to give that negative sign to everyone. I have to distribute the negative. That is where students get confused. Distribute to everything. Distribute. Distribute the negative. Okay? So this is going to be minus 3x squared minus 7x. Then I've got a negative to a negative. So what does that become? Plus. Be sure you have given that negative to everything in that trinomial. Be sure that you've done that. Okay? Now I combine like terms. 7x squared minus 3x squared. Is that going to be 4x squared? You got to review those negatives if you're having trouble with those. Let me know. Negative 2x, negative 7x. I heard it. Negative 9x. A negative plus a negative is always a negative. And you add their absolute values. Okay? The last one. Negative 4, positive 1. It's negative 3. Negative 4 has the greater absolute value. That's why you take that sign. And then you subtract. Okay? Then you subtract. Okay? Okay. I can come back to this after class. I just need to move on for time. Okay. Here we have three quantities that we're dealing with. Okay, we've got three different quantities. We are only subtracting the middle one. So my minus sign only needs to be distributed to that middle binomial. Okay, so my first binomial, I'm just going to write down 5a squared minus 2b. My second binomial, I need to give that negative to both of those. Give that negative to both of those. Okay, so I'm going to have negative 2a squared, negative 4. Negative and a minus are the same thing. Whoops. Okay. Then I have plus negative 7b minus 3. I don't distribute the negative to the negative 7b minus 3 because I am adding. I am adding right there. Okay? That's why I don't distribute it. So, 5a squared minus 2a squared, 3a squared. Negative 2b, negative 7b, negative 9b. Okay? And our last one, minus 4, minus 3. They're both negatives. Good. Okay? So that they're both negatives, so it's going to stay negative, and I take the sign. Or I add their absolute values. I take the sign and I add their absolute values. Okay? Now, I want to go, we'll come back to this because I think we'll have time. This is super important. When we are adding and subtracting monomials, the exponents do not change. Now, students typically don't mess up with this until after I teach my next lesson. Okay? So, if I have 2x squared plus x squared, the answer to this is 3x squared. The wrong answer to this is 3x to the fourth. Okay? The wrong answer to this is 3x to the fourth. And students will say, but don't we add the exponents? We add the exponents when we are multiplying. When we multiply. Okay? We add the exponents when we multiply. So if I had 2x squared times x squared, that is when I multiply. That's when I multiply. Okay? This is not when I add the exponents. I don't add the exponents then. Okay, so be careful of that. And typically students don't, hold on, I've got 2 more minutes. Typically students don't make that mistake until after Wednesday's class, but be on the lookout for that. Now, here's another one. I'm going to do it fast because I've got 2 more minutes. Okay, I have 4t squared minus 7t minus 1. I need to distribute that negative to everything. I need to distribute that negative to everything. So it's going to be minus t squared minus 2t plus 6. That negative, you've got to give that negative to everybody. Okay? 4t squared and minus t squared. 3t squared. Negative 7t minus 2t. And negative 1, positive 6. Good. Okay? Okay, I will see you guys soon.